Hello Precalculus student, this video is for chapter 6.2, graph of other trig functions, meaning tangent function, cotangent function, secant function, and cosecant function. So we'll look at tangent and cotangent first. And to begin with, I'll just look at tangent function. Tangent function, here is the graph of the tangent function, and here is some table that I make. If you look at plug in the different x value, which is the input of the function, and then the tangent, you notice that at negative pi over 2, tangent is sine over cosine, right? Cosine negative pi over 2 is 0, and also at pi over 2, cosine is also 0. So they will be the tangent function is undefined. So, and also when it is close to the undefined pi over 2 value, the tangent values goes up to infinity or go down to infinity at the two sides. So it becomes a vertical asymptote. So tangent function is not a continuous function. It breaks up into parts where there are asymptotes. And they are always at pi over 2, negative pi over 2, 3 pi over 2. And if you look at the how the function graph goes, in between two asymptotes, the function goes from negative infinity to infinity, and in the middle, it goes through is 0. So this is the only intercept, because at the basic function or the basic cycle, which span from negative pi over 2 to pi over 2, you see that at 0, 0 that's the middle, and it's the tangent function is 0 because sine is 0, but cosine is 1. 0 over 1 is 0. So this is in general how it look like. You can say that tangent function is always increasing. So once we increase to negative infinity, it would be close to a asymptote, and then it go back to it would go to infinity, and then it would go back down to negative infinity and increase. And this particular behavior repeat every pi, right? So the length of this one cycle is pi, from negative pi over 2 to pi over 2. Okay, we do not start the cycle from 0 like in sine or cosine. The cycle start from two vertical asymptote. The first one is negative pi over 2, the other is pi over 2. And all of the other vertical asymptotes are from pi over 2, or from pi over 2 plus and minus another pi. So that is in general how a tangent graph look like. We can look at Desmo to graph it. I changed the settings, so the x-axis has steps of pi over 2. And also we would graph tangent x. Oh, okay. I should change it back to not dotted. I was trying to show here like that. Change back to solid. Okay. So this is the tangent function. So you can see that it has 0, 0, and this is the main cycle with two asymptotes bounding it. And I cannot draw anything. So 0, 0 is the point that it's is right in the middle, and this is a vertical asymptote x equal to negative pi over 2, and this is the right hand side vertical asymptote is pi over 2, and the whole thing is pi. Right at the middle, or at the quarter point, you still have quarter point. So let's say x equal to negative pi over 4. If I change this to dotted, you can see that this meet the graph at negative pi over 4, negative 1. And then if I do a positive, it would be here, it would be 1. So these are the two quarter point, pi over 4, negative pi over 4 at negative 1 and 1. Now, so it used to be we have amplitude here. We have amplitude in sine and cosine, but in tangent we don't have amplitude. but at the quarter point, it does go to 1 and -1. So we can kind of change, you can kind of refer this as to like a special point, a special quarter point value that would be affected by amplitude. Okay. So let's look at the basic tangent function. The basic period is from -2 to √2 with vertical asymptote at the two ends. The period is pi. There's no amplitude because tangent x approaches infinity near the asymptote. But we still record A as the stretching factor. Later on, we'll talk about doing a transformation of A tangent Bx. A is called the stretching factor. And the stretching factor will affect the quarter point and the 3/4 point. So instead of at 1, it would be at A and -A. So there are a lot of vertical asymptote. They repeat every pi. So we say pi/2 plus n pi, -pi/2 plus n pi. So domain of the tangent function is all real number except at pi/2. Every pi/2 multiples, it would not be a it would not be in the domain. The range is all real number. So it is periodic, but it still go to infinity. Okay. So so this is like kind of the basic one. When we look at the basic function, we have to quote instead of 5 key point, we actually quote 2 vertical asymptote and 3 key point. Okay. So the 2 VA would be x equal to -pi/2, x equal to pi/2, and then the 3 key points would be the quarter point. Here we talk about those in the decimal graph. -pi/4, it go to -1, and at pi/4 at the 3/4 point here, go to 1. Okay. So, but if I multiply a tangent by A and B, A outside and B inside, A used to affect the amplitude, but not now. It would we call it affecting the stretching factor. So it's a vertical stretch. So the stretching factor is A. If A is less than 0, that's reflection. If it is, when the graph reflects, then instead of, we can use decimal to show. So if I have a -x, what would it look like? So, okay, maybe I'll just have both. Or look carefully. So if I have positive, it would be going up. If I have negative, it just flip over, it goes down. It's still -pi/2, pi/2. But at the 2/4 point, instead of going to -1 on this side, it would go to 1 on this side, and it would go to -1 on the other side. So that's reflection. What is the period? The period is pi. Okay, so the new period will be pi/b if you have bx inside the tangent input. Now, how do I find the vertical asymptote on the left and the right if I have bx? So basically, it would be a -pi/2b. That means it is half of the period to the left, half the period to the right. If you don't want to remember these, so this is the repetition. What you can do is for the basic one, you solve for bx equal to pi/2 and bx equal to -pi/2. You'll figure out, solve this two function. You will figure out what the two vertical asymptote would be. Okay, so let's do some practice. So I have a graph, or I need to graph y equal to -1/2 tangent pi x. What is the period? Now the -1/2 is actually that indicate reflection, and also the stretching factor is 1/2, but it does not affect the period. The period is affected by this number that multiplied to x. So b is pi. So the period for the basic one is pi, and you have a b also pi. So period is 1. So that means your graph has the two sides has a vertical asymptote, and the whole thing is 1. That means it is 1/2 here and -1/2 being the two vertical asymptote. Okay, it's always half of them. Okay, half of the period. So let's just get a feeling as how this transformation works. If I am to graph one cycle, or actually one cycles of 2 tangent 1/3 x. Let's record the stretch factor is this a number. So absolute of a. Absolute of a is 2. So that means it affects our quarter point and the 3/4 point. What is the period? Period is pi over 1/3. Pi over 1/3 is pi times 3 over 1. That is 3 pi. Okay, what is the left VA? I will just do 1/3 pi equal to negative pi over 2. So this is just the old one. And what is the new one is times 3, right? Negative 3 pi over 2. So negative 3 pi over 2. That makes sense because, cancel. Um, and then the right would be, it used to be pi over 2, so you just use this to solve it. 1/3 x equal to pi over 2. X is equal to 3 pi over 2. So that's the way to find them. 3 pi over 2. X equal to negative 3 pi over 2. This is negative 3 pi. So, but we want to do this quarter point to graph, right? So the quarter point would be from 0 to 3 pi over 2. What is it? Just 3 pi over 4 because you're going to divide it by 2 or times 1/2. This would be negative 3 pi over 4. And because my stretching factor is 2, so instead of going to 1, this go to negative 2 and 2. 0, 0 is always, and so we graph it this way. So let's say we have the VA, and now we have 3 key points, right? 3 key points. What are the 3 key points? So this is the negative 3 pi over 4, but it's negative 2. 0, 0, because the tangent is 0, 0. And also 3 pi over 4, it go to 2. So remember, always increasing. That's the tangent function. And if you repeat another set, you will have another branch. Okay. Like that. So that is the tangent function. Oh, the 3 key points. Let's graph another one. One more, practice one more. So this is the stretching factor is absolute of A. A is negative 3, B is 2 pi. So absolute of A is 3, right? It's stretched by 3. And there is a reflection over x-axis. For the left VA, we need to solve a 2 pi x equal to negative pi over 2. Just solve this. X equal to negative pi over 2 times 1 over 2 pi, right? Because I divided by 2 pi. What? Negative 1/4? Right, negative 1/4. So we have no more pi x equal to negative 1/4. And then the right VA would be 2 pi x, whatever that's inside, equal to the old VA, pi over 2. So divided by pi over 2, x would be pi over 2 times 1 over 2 pi, because it's dividing. So it's 1/4. So this side is 1/4. This should be symmetrical. So it used to be negative pi over 2 and pi over 2, pi over 2. To solve the new one, you get the one that is in the argument of or in the input of the new transform function, and you would solve the new asymptote. So what is halfway between 0 to 1/4 is 1/8. Halfway between negative 1/4 to 0 is negative 1/8. We're ready to graph, right? So there is a reflection. So it used to be going up like this. After the reflection, it goes down. So this would be the 3 key point, right? Okay, so our 3 key point would be this one, negative 1/8, comma, there's a stretching factor of 3, right? And used to be 1, but now it is negative 3. So 3 first. And 0, 0, and 1/3, but it would be negative 3 because of a reflection. So that's how, in general, how you graph the tangent function.